Hi, I'm Darryl Chandler, Certified Master Inspector and Lead Senior Inspector for Focus Property Inspections, here today to talk to you about septic systems. Septic systems, or subsurface wastewater disposal systems, are comprised of four major parts. The first is the plumbing coming out of the house. The second is the tank. The third is the leach field, and the fourth would be the soils around the leach field. The first section, the plumbing section, is designed to get the liquids and solids out of the house. It does this by being pitched at 1/4 to 1/2 inch per foot drop. Any more than that, what happens is the water moves too fast and the solids clump behind, and we end up with a backup eventually over time. Any less than that, well, everything kind of stays behind. So we want the water to push the solids, go over the solids, come back around, lift the solids as more water is pushing, and that tumbling action then clears the pipe all the way out to the tank. The second section, the tank, is designed to separate the liquids from the solids. It does this by being separated into three chambers. The first is an inlet chamber, the second is a processing chamber, and the third is an exit chamber. As the water and solids come into the tank, the inlet chamber is separated from the processing chamber by an inlet baffle. That baffle's job is to make the water turn underneath itself like this, allowing the heavy stuff to sink to the bottom and the lighter stuff to pop up and float across the top. That floating layer is called the scum layer. The sinking layer is called the sludge layer. The water layer in between is called the affluent water layer. As the water and the solids make their way across the processing chamber, that second chamber, biodegrading starts to take place and more separation starts to happen, so the water can start to clear itself as it migrates across the tank. When you get to the third section is separated from the processing chamber by an exit baffle. That baffle's job is to simply hold back that floating scum layer so it can't leave the tank. Basically, it acts as a straw. You got ice at the top, soda at the bottom. You don't want the ice, so you use a straw to go down. It doesn't quite go all the way down to the bottom. So only the water can get up underneath it. The heavy stuff on the bottom stays on the bottom, and the lighter stuff at the top can't sink and get underneath it. So only the affluent water gets out into the system. You flush the toilet, 1.6 to 1.8 gallons of water plus whatever you put in the system comes rushing out, and on the back side of the tank you get 1.6 to 1.8 gallons of rise that leaves the tank and goes out into the field. The third section, the bed, leach field, drainage field, it's called all kinds of different names, but the idea behind the field is to allow the water to safely percolate back into the environment. It does this by being comprised of layers. The first layer is Mother Earth. The second is usually sand, and then usually crushed stone where we lay our pipes. Above that, usually a little bit more crushed stone, some kind of geotech or straw or hay to keep the topsoils from going down through and clogging the bed, and then more sand. And then above that, topsoil and grass. There's supposed to be at least 4 inches of sand or soil above a bed and at least 12 inches below and on the sides. As the water comes rushing into the distribution box of the bed, which starts at the beginning of the field, and out the pipes, which have holes at 5 and 7 o'clock to allow the water to go into the crushed rock. The crushed rock holds open an air void so that the water has an immediate place to go. The filtration actually happens in the sand. If anybody's ever had a pool before, you have the big sand filter beside the pool that water rushes down through and catches all the particulates that are floating around inside the pool. It's exactly what the bed does. As the water passes down through the sand, it catches all those bioparticulates and holds them up. And the water keeps continuing down and eventually back into the aquifer. And then you've got the air-breathing bacteria that will actually consume all the bioparticulates. As long as the rate of infiltration of bioparticulates is less than the rate of consumption from the bacteria, the bed stays clean. When the rate of infiltration exceeds the rate of consumption, then what happens is the bioparticulates start to mat up onto each other, and they cause what we call a biomat, which actually just seals the bed shut, acting like a pool liner. It doesn't allow water to go down, so the bed starts side leaching left and right, which is a perfectly acceptable practice until that water table gets to be at or above the crushed stone or at or above the proprietary leaching device in the field. Section 4, the soils around the leach field. Basically, your inspector is going to either run a camera out into the leach field or dig a test hole to evaluate the condition of the soils around the bed. As I mentioned before, bioparticulates getting into a bed is the #1 reason why things fail. Having said that, in an active bed, we do expect to see some coloration and some active soils around the bed. What we don't want to look or don't want to see is that bioparticulates becoming a biomat. At that particular point in time, it contaminates those soils and stops the percolation or the actual transfer of the water from the bed back into nature and back into the aquifer. So now that we've talked about the components of a septic system and how they operate, let's talk about how you should operate your septic system. The first thing you want to make sure that you're aware of is that it's a bacteria operating system, and keeping the bacteria level healthy is key to longevity of the septic system. Try not to do things that'll upset or decrease the amount of bacteria in your system. Stay away from using antibacterial products like hand soaps and body washers that are antibacterial. Don't use bleach. Bleach will naturally kill off the bacteria in your bed and in your tank, and while that's happening, more bioparticulates are getting out into your bed, forming that biomat, which will clog the bed over time. Stay away from putting things that don't break down into your system, like latex paints or paints. First thing people like to do when they move into a house is paint it. Washing your brushes and rollers out into your sink, that paint will stay water soluble and float out into your bed, and eventually the sand will filter it out, but it'll clog the bed shut. Trans fat, like bacon grease and chicken fat, will actually clog the bed too, and it doesn't break down. Pour that off into a can, let it solidify, throw it out in the trash. Don't put it out into your septic system. Don't flush things in a non-biodegradable. Feminine hygiene products, cigarette butts, diapers, diaper wipes, paper towels, or any kind of wipe that comes wet that you use to clean products with. That stuff doesn't break down and eventually will clog the system. A lot of that stuff comes with antibacterial products in it as well to keep it smelling fresh and clean. Old medicines, don't flush old medicines. Most of them have antibacterial products which will actually kill the bacteria off in your bed. One of the biggest questions people ask is, how often should you pump your system? We use the rules of 7. Basically, the rule of 7 says, take the number 7 minus the number of people living here over the age of 7, and that's how many years you should go between pumping. So if you had 3 people over the age of 7, you take the number 7 minus 3, you would pump every 4 years. Our website will have an actual chart that'll list out when you really should pump. That is just a guideline so that you don't have to actually excavate your tank and check your scum layer to see how thick it is to decide whether or not you have to pump. The other thing you want to stay away from is using any additives. Bacteria additives do a great job at doing what they're supposed to do, but they're too good. They clean the system up too efficiently. You want the bacteria level to balance itself out based upon the natural flow of food coming into the tank and into the field. By adding the additives, you throw the bacteria count too heavy in one direction, which kills off or eats up and kills off the food in the system, which then the bacteria dies off because it doesn't have food to sustain itself. Using your system on a regular basis puts the bacteria in there that you need to keep it balanced. Mother Nature provides all that you need by just using the system. If you need additives and they're a good product, you should be under some kind of professional supervision and not just doing it by yourself. I want to thank you for taking the time to watch this educational video on septic systems. If you have any further questions about septic systems, how to maintain them, or how they operate, please feel free to ask your inspector or visit our website below. And if we at Focus Property Inspection can be of any further assistance, please feel free to reach out. Thanks again.